Hello, this is Mr. Win with piecewise functions for this video. And this is for pre-AP only. If you're regular, you do not have to watch this. So piecewise functions are pieces or parts of multiple graphs on the same graph. Each equation will come with a domain restriction because we only want one piece of it, not the whole thing. There are two ways to graph it. The slow way is to graph each equation and then erase the unnecessary part. Or the smarter way and faster way is to find the key points for each piece, such as the starting points and end points, and using that. Now, there's only one key point, or like one end point, but no other points. We can find another point in the domain and like connect them, or we can use characteristics or knowledge of the parent function. For example, if it's a u, we know it's going to be, or it's quadratic, it's going to be a u shape. All right. Also, when finding domain and range, it's kind of hard here. Be very careful of the overlaps and gaps. All right. You must use the or for every gap if you write in inequality or set builder notation. And if you remember for interval notation, ORs are the U, the union sign. So here's an example of a piecewise. So let's graph it, then answer the bottom questions. So this graph, f of x, has two pieces. It has this top piece right here, and this bottom piece down here. So we use the top piece for every x value greater than 2. So on the right side of 2. Then we use the bottom for every x less than or equal to 2. So add 2 and to the left. So let's use the first one. I'm going to find the endpoint. If the boundary is at 2, I'm going to plug 2 into this equation. So I'm going to do 2 plus 5. That's 7. So when x is 2, y is 7. I know that's my coordinate I'm going to use. So I'm going to go ahead and graph that now. So 2, 7, but open. So I'm going to write 2 up 7. Should be here. 8, 9, 10. Yep. That's 2, 7. And then I'm going to go to the right because x is going to be greater. So if we use some common sense here, we know that this is a linear graph. And we look A, actually. The slope, or you can say the steepness of the graph, is normal. It's not stretched or compressed. It's going to be exactly 45 degrees. So I know it's going to do this. Now, if I didn't know that, I could actually just plug in a point. I could plug in, for example, 4. I'll see what's 4 comma something. I don't know, I'll use the same color. So 4 comma what? So I plug in 4 for x. 4 plus 5, that's 9. I should have point 4, 9. Now I did sketch, but let's see. 4, 9 is right here. So that is on my line. Alright, so the first piece done. Now the other piece. It says use this second one when x is less than or equal to 2. So again, the boundary's at 2. So I'm going to plug in 2 for sure to see what I get. So let me do like this. If I do negative, I'm plugging 2. Negative 2 minus 4, that's negative 6. And the coordinate, it would be 2 comma negative 6, and now it's closed. So 2, negative 6 down. 1, 2, 3, 4, 5, 6, and this is closed. 2, negative 6. And then if I look at this, I know it's linear with the a value of negative 1. 1 doesn't stretch or compress it, but the negative flips it. So it'll be an upside down line. So I know it's perfect 45 degree angle slope, so I know it's like this. But if you didn't know that, you could, like I said, plug another point. So I'd need something less than 2. I could try 0. If I plug in 0, negative 0 minus 4, that's negative 4. I know the other point or the line should have 0 comma negative 4. So see how close my line was? 0, 1, 2, 3, 4, right there. 0, negative 4. All right. So there you go. This graph has two pieces. There's a line with a negative slope for the left half and a line with a positive slope for the right half. All right. Is this a function? Does it pass the vertical line test? If I drag a line, let me just do like this. If I drag this line over the graph, does it touch twice at any point? So it touches once, only the green line. It's the only green line. Right here, it touches red and green, but look, the bottom one's closed, it counts, the top one's open, it doesn't count. So this is still a function. This passes the vertical line test. So the answer is yes. It's still a function. The domain is left to right. How far left do we go? And are there any gaps? Well, for the green part, it goes left forever. So it'll be negative infinity. And for the right, let me do like this. I'll use this blue line again. This green part goes to negative infinity all the way to 2, closed. Now, if I move forward, was there a gap? Do I skip everything? No, the moment I scoot over, the red takes over. So there is no gap here. It keeps going. It's smooth, continuous. So it goes all the way to positive infinity. So this would be our RO numbers. All right, for the range, it's low to high. So let me draw I'll draw another blue line. All right. So low to high, how low does it go? This graph goes all the way down to -6. -6 closed. How high does it go? Well, this green piece goes up forever, and it overlaps this red piece, which is fine, but it keeps covering it all the way to positive infinity. So here, I don't even need to look at the red line for range. All right, or we could say y is greater than or equal to -6, because it'd be greater than the first number. All right, now you could also do interval notation, set builder notation. I'll do this, I guess, or y such that y is greater than or equal to -6. All right, now we can just stick to interval notation. That's the easiest. So that's the easy one. Now time for a harder one. So they're going to be more than 2 pieces. So graph the following piecewise and answer the 3 bottom questions again. So this top piece, 2x, if x is less than or equal to -3. So I'm going to plug that in. -3 comma what? So it'll be 2 times -3 is -6. So I know that's the coordinate I have for sure. So I go to my graph and put -3 comma -6. -3, 2, 4, 6. And this is open. Alright, so this is -3, -6. Alright, then I'm going to graph it. I see this is 2x, that's linear, and it's vertically stretched, positive slope. So I can't go to the right because I'm on the left side of -3, but it should be going like this. And again, if you don't know your parent function characters, just pick another point. I'll pick a point to the left of -3. Say I pick -4. If I do 2 times -4, I get -8. I should have the point -4 comma -8 in here in my check. -4, -8's right here. It is on my graph, so I'm good. My sketch is pretty good, pretty accurate. Alright, so that's for the That's for the first piece. I'm going to do the second piece now. So now I'm on this middle one. It says look at this line right here and use it, this line right here, if x is between -3 and 1. Well, that gives us 2 endpoints. We need to be at that point and this point. So I'm going to plug in -3 and +1 into the equation. So let me do it like this. Delete, delete, delete. Alright, if I plug in -3, let's see what I get. -3 plus 4, that's +3 plus 4, that's 7. So -3, 7 is on the picture. And that is closed. So let's see, -3, +7 is right here. -3, +7. Alright, I gotta plug in 1 as well. So as I plug in 1, -1 plus 4, that's +3. So 1, 3 is right here. That's also closed. Now connect it. Alright. I mean, you do see the slope is -1. So it's flipped, perfect 45-degree angle, if I drew it correctly. I didn't draw a straight line, but that's okay, close enough. Alright, so the middle piece is done. Now with the last piece, we have -4 if x is greater than or equal to 5. Or sorry, it's greater than 5. Now if I plug in x, it doesn't change the -4. That's a constant. It's a line, a flat line. So I'll find 5 for x. 1, 2, 3, 4, 5. I go -4. 1, 2, 3, 4, 5. It is open. And we're going right of 5. Greater than 5 is right here. So alright. So that's all 3 pieces. Now I gotta answer the questions. Is this a function? Does it pass the vertical line test? So the vertical line test, I'll just draw the straight line. Does my function touch the black line at more than 1 point? For this green line is taking care of the left side because it goes down forever. Right here, it touches green and blue. Now my line's not straight. But for the top, it's closed. For the bottom's open, so it's fine. It's just 1 point. Here it's good, just 1. Here's a gap here, but that's okay. As long as x is not repeated twice, we're good. Then here it's touching once, so we're good. So yes, this is a function. The domain is left to right. This graph goes left forever. So -infinity. How far right? Well, let me use this line again. So it is green, green, green. Here's the part where green stops, but the blue starts taking over. So the blue is connecting the green further, 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 and the blue stops right here. If I go forward, there's nothing else catching it. So actually, The green and blue combine for negative infinity all the way to +1, closed. Then we have a gap here from 1 to 5. There is no x values used. You can't give me a point for 2 comma anything or 2.5 comma anything or 3 comma anything. All right, so we start again here when x is 5. So I'll say union. X is 5 and 5 is open. How far right does it go? +infinity. So when there's a gap, you have to use a U for union. Same thing for range. So let me make a black line. Let's hopefully make it straighter. All right. So how low does it go? It goes forever. This blue line, this green line goes down forever. Goes all the way up to -6. From -6 here, there's a gap. There's nothing there. So it's my first piece. So I'll use green here. So it goes from -infinity all the way to -6. -6 is open. We have a next piece. This next piece, if I scoot up, actually is the red line. Oops, undo that. This red line is only at -4. So -4 is by itself, so let's put this at 4. Then we have union again, because there's the missing gap for y's. There's no y values at, for example, -1. You can't tell me any x value that gives me a y of -1. Keep going up. Right here's where the next section, the blue part. It goes from 3 all the way 7, and there's nothing past 7. So union 3 to 7, they're both closed. And you could change that to set notation as well. It's a lot of things. You just put ors. So if you want to do that, I'll do like this. You could say y such that, and then you can say the first one, y, oops, what happened? Y is less than or equal to -6, or y equals 4, -4 I mean, it's a negative, it's that negative sign, or 3 less than or equal to y less than or equal to 7. So there's that one as well, but if I were you, I'd stick to interval notation. Alright, that's piecewise functions. Hope you enjoyed the video. Make sure you ask me questions in class. We'll do some more examples, obviously. But thanks for watching. See you soon. Bye.